Hi guys, welcome to my channel and welcome to my SSCE mathematics series from zero to guru. In this video, I'm going to introduce another topic known as indices. Here, I'm going to revise how you can express number in an index form and how you can apply index form to indices, how you can apply indices to find the square root of number. If you don't forget, in the previous video, in particular number-based system, we have this kind of number 101 base 2. So, and this number is read as 101 subscript 2. You understand now? We say this number, is said to be in a base 2. So likewise, if you don't have subscript, you can as well have a number in superscript. For example, if I have 101 base 2, this type of number which is 101 base 2, meaning 101 multiplied by 101. So this 101 base 2 is said to be in index form. It's said to be in an index form. You understand? That is, when we say a number is in index form, it means you are going to multiply by the number by itself. So in the number of the index. So for example, if I have 2 raised by 3, it means I'm going to multiply 2 by itself 3 times. You understand? Likewise, in general, if I have a raised by m, then I'm going to multiply a by itself how many times? A times. So m times, sorry. So m times. So when you have such a number, we said it is in index form. Note that when I say index, the plural form of index is indices. The plural form of index is indices. And it is very simple. When you have a raised by m, then your a is said to be base, then your m is called index or power. So in essence, a raised power m can be pronounced as either a raised power m or a index m or a superscript m or a raised power m, which I've said before. This is not the first time you will come across this number. In particular, when you were in your junior secondary school as well as your primary school, so you've been taught how you can express number in an index form, and how you can use indices so to find the square root of a number. So in the remaining part of the video, I'm going to explain and revise how you can apply index form to find this number, to solve this kind of problem. For example, if I have express 500 as a product of its prime factor in index form, as a product of its prime factor in index form. Again, we all understand what index form means. That is an expression or a number in this form. So a raised power m, meaning that is a number multiplied by itself m times. You understand now? So that's index form. Okay, what is prime factor? So before I explain what prime factor means, let me revise what is factor to you if you don't forget. Factor means a whole number that divides a number exactly. You understand? For example, if I have 4, the factors of 4 are 1, 2, and 4 itself. That is the number that can divide 4 without remainder. So 2 is a factor of 4. So because 2, you can divide 4 by 2. 3 is not a factor of 4 because you cannot divide 4 by 3 without remainder. Because 4 divided by 3 here, you will see is going to give you 1 and 1. So that's that. Also, we call something prime number. Let me remind you. Prime numbers are those numbers having how many factors? 2 factors. So that number, the number and 1. You understand now? So that is when you now have a number and you find out that such a number has two factors, so itself and 1, then you conclude adequately that such a number is what? Is a prime number. For example, 2. You can see that 2 has how many factors? 1 and 2 itself. So then 2 is considered to be a prime number. What of 1? Is 1 a prime number? 1 is not a prime number. So because 1 has just one factor, you understand now, 1 has only one factor. And don't forget, by the condition of prime number, a prime number is such a number that has two factors, so itself and 1. It must not be greater than 2 or less than 2. You understand now? Another example of prime number is 3, because 3 has two factors, 1 and 3 itself. So 4 is not a prime number because 4 has how many factors? 3 factors, 1, 2 and 4. You understand now? So when you now have a number, take for example, if I have, for example, 15. If I have 15, so you know the factors of 15 are 1, 3, 5 and 15 itself. Of all these 4 factors of 15, you will notice that only 3 and 5 out of the numbers are prime. 3 is a prime number, 5 is also a prime number. So the factors of a number that are prime are called prime factors. So in essence, 3 and 5 here are what? Are factors of H, are prime factors of 15. Are prime factors of 15. Likewise, when you have 20, you know the factors of 20 are 1, 2, 4, 5, 10, and 20 itself. So of all these numbers, you will observe that 2 and 5 are what? Are prime. So because they are prime and they are also factors of 20, they are considered as prime factors of what? Of 20. If that is clear now, if we go back to our question, we are asked to express 500 as a what? As a factor of, as a product of its prime factor in index form. So then what we are going to do is to divide by its prime factor until you have what? Till you are left with 1. So I mean, one needs to do this is, if I were you, I would just write the prime numbers. You know, an example of prime number are 2, 3, 5, 7, 11 in this order. So you now take this prime number one by one and check whether they can go in 500. So if they cannot go again, you take the next number. You know the first prime number here is 2, which is also a factor of 500. So you know 2 can go in a number according to your divisibility rule. So we say a number 2 can go in a particular number. If you check the last digit of that number, and you observe that the last digit is either 0 or H or even. If it is 0 or even, then you say 2 can go, you can say 2 can go in that number. So how many 2 are we going to see in 250? 500. So 2 in 500 is 250. 2 can also go again because we check the last digit, it is 0. So then according to divisibility rule, 2 can still go. So 2 in 25, that's 12 remainder 1. 2 in 10, that is 5. Can 2 go in this number again? No. Because if you check 5, which is the last digit, it is neither 0 nor even number. Then you now check the next prime number. So is 3 a factor of 500? No. How do you know that 3 cannot go in, 3 cannot go in 125? How do you know that? By divisibility rule of 3, we say 3 can go in a number when you sum all the digits together and it gives rise to a number that 3 can go in it. For example, if I have 1, 8, which is 18. 18 is a multiple of 3, that is 3 is a factor of 18. 3 can divide 18 because when you add the digits together, which is 1 plus 8, you are going to get 9, which is a factor of 3. But 125 here, 3 cannot divide it. So because what? When you add the digit together, 1 plus 2, 3 plus 5, which is 8. So you will notice that 3 cannot go in 8. Then 3 cannot go. Then you take the next number, which is 5. 5 in 125, that is 25. 5 in 25, 5. 5 in 5, 1. Then after that, you are now going to say 500 is equal to 2 times 2 times 5 times 5. So we've expressed it in what? As the product of its prime factor now. So now in index form, to take this number to index form, how many 2 is this? That's, we have 2, 2 appears 2 times. So since they multiply themselves, then you are going to have 2 raised to power 2. So then multiply by 5. How many 5 do we have here? So 5 times 5 times 5, 3 times. Then you are going to have 5 raised to power 3. Then we've taken this number, so we've taken it to, index form. You understand now? But when you have, like I've said the other time, the plural form of indices, when you have many index, so number, then you said, we arrive to what we know as indices. So one of the applications of indices, if you've not forgotten, is how you can use it to find the square root of a number. If you've forgotten, let me remind you, remember that square of a number is the product of the number and itself. For example, if I have 7 raised to power 2, 7 raised to power 2 is what? It is the same thing as 7 squared. That is 7 multiplied by 7. You know 7 multiplied by 7 here is what? 49. You understand now? So that is square of 7. This means square of 7. The square root of 7, square root of 49, which is denoted by this, so is what? Is 7. 7 square is 49, then square root of 49 will be 7. So what does that mean? So in a layman language, it means that when you have square root of 49, that is, what are you going to multiply? What is the number you are going to multiply by itself 2 times to give you 49? And as you can see here, we multiply 7 by 7 to give us 49. Although when you reach higher level, so we say that, so the square root of 49 is plus or minus 7. So because by the principle I told you the other time, that when you say square root of a number, basically you mean what is such a number that when you multiply such a number by itself 2 times to give you the number in the radical, which is inside the root. So for example, 7 times 7 now will give you 49. Likewise, minus 7 times minus 7 will give you 49. So in essence, a number can have 2 factors. So that is, when you have a number, the square root of number, so you can have its root to be positive as well as negative. So how do you now apply indices to find the square root of this number? For example, find the square root of 100. So that's not difficult to do. What you are going to do first is to express as is the product of its prime number in a prime factor in index form, like we've done the other time. This 100, the first prime number that can go in 100, which is also a factor of 100, is 2. Then you take it, 2 in 500 is 50. 2 can still go again. 2 in 50 will give me 25. 2 cannot go again because we observe the last digit here. It is neither 0 nor even. So then you consider 5. So because 3 cannot go as well. So 5 in 25, that is 5. 5 in 5 is 1. Then you are going to say 100 is equal to 2 times 2 times 5 times 5. So you notice that we compare this number together. So when you have a such pair, maybe 2 square multiplied by 5 square, which you could as well could be written as 2 times 5 multiplied by 2 times 5. You understand now? Then I have 10 times 10. You can see that what is such a number that I multiply by itself 2 times to give me 100. It is 10. And you can conclude that square root of 100 is equal to 10. It's as simple as this. So likewise, in your WAEC or NECO or JAMB you may have a question, you may be asked to find the least number by which a number can be multiplied to give a perfect square. What is a perfect square? Perfect square are those numbers you can find their square root. For example, when I have 1, when I have 4, 9, 16, 25, 36. All these numbers like this, you can see that I can find their square root, and their square root gives a whole number. So if a square root of a number give a whole number, then that particular number is said to be what? To be a perfect square. Example 1, 4, 9, 16. So in your exam, you may be asked to find, or to simplify, or to get a simple number or the smallest number by which that number can be multiplied to give a perfect square. For example, if you have something of this nature, what number, what is the least number by which 50 can be multiplied to give a perfect square? To give a perfect square, that is not difficult. What you are going to do is to what? Is to express in index form. You know we have 50 here. So the smallest factor of 50 is 2. Then you divide it, 2 in 50, that's 25. 2 cannot go again. 5 can go, that's 5, 5, 1. So you notice that I have 50 is equal to 2 times 5 times 5. And don't forget, before we can find square root of a number, we should be able to pair such a number, so such that if we are regrouping it, so we are going to have representative from each of the, pairing. So you will see that I have 2 times 5 square here, but this one, so it doesn't has, the partner. So 2 has no pairing. So then for us, or for this number 50 to be a perfect square, each of the numbers here so must be what? So must has a pair. So that is their power must be raised to power even. So it means for this number to be a perfect square, then I'm going to have it multiplied by 2 again, such that I'm going to have 2 to be paired together as well. And I'm going to have the representative 2 as well as 5, so that if I combine them together, I'm going to have 10. You understand now? Then I say the least number is 2. You understand? Likewise, if you want to do this again, for example, suppose you want to try it for 35. If you want to try it for 35, that is, what is the least number that will be multiplied by 35 to give a perfect square? You take the prime number that can go in 35. So 2 cannot go, 3, but 5 can go. So 5 here, 7, 7 can still go again. That is what? That is 7. So you will see that 35 is equal to 5 times 7. But you will see that this number has no pair, and before you can say their perfect square, before you can find their square root, you should be able to have it paired in such a way that their power will be what? So will be in the form of even number. So it means for this number to be, a perfect square, then I must have another 5 here, multiply by, then I must still have another 7 here, such that we compare them like this. So then the number that must multiply by 35 to give a prime number, a perfect square, is this new number we introduce. So which is 5 and what? And 7. So that's 5 times 7, which is 35. Then 35 must be multiplied by 35 to give a perfect square. And you will see when I multiply 35 by 35, 35 by 35 is 35 square, which is a perfect square. Likewise, if you look at the first example here, which is 50, the least number is what? Is 2. And I multiply 2 by 50. So 2 by 50 will give me 100. You notice that 100 is a perfect square. And that's how you are going to get it. If I were you, I will refer to my past question and solve questions, that are related to this. If I have any problem, I'm going to put it in the comment section. If you enjoyed this video, please don't forget to like. If you've not subscribed to my channel before, please don't forget to do so, and don't forget to inform your colleague to do so. Thank you. See you in the next video.